Good afternoon, everyone. It is, what is it, February 9th, 2022, Wednesday. We're going to work on 3.3. We're going to touch on it's really quick. And then we're going to do 3.4 and 3.5 in our chapters for Math 21, Intro to Stats. So 3.3 is on, we're going to just do it really briefly. It's on weighted means or weighted averages. And this is a topic that relates very much to you guys because this is how grades are calculated, or your GPA. GPA is a weighted mean. So what they do is they use W for the weight. And if they have W with an I, like a sub-index, it's weight of the ith item. And then we have our regular XI kind of thing. Or X, I should say. And the way the weighted average is, so it's an average, and they use a little W there to say it's weighted. We used to just do the sum of all the XI, and then we divide it by N. Well, now we do the sum of the XI, and we multiply it by each of their weights as we do it. And then rather than doing the sum of all the XI, we do the sum of the weights. Okay. So what does that mean here? In terms of GPA, how it applies to GPA, the weights are the units for each class. And your XI or your X scores are your grades. So for example, let's say you get an A in Math 21. An A, that's a 4-unit course. And an A is worth a 4.0. And let's see, let's say English 1, I think it's also 4 units. You get, let's say you get a B there. And a B is 3 units, or 3, GPA of 3. That's an arrow. And let's see, what else can we throw in there? Let's say, I don't know, PE. Let's say there's a 1-unit course for PE. I don't know. And let's say you're lazy like I am, but you get an F. So you get 0 units there, or 0 points there. The way you calculate your GPA, let's say this is just your first semester and this is what you get. That's clearly not enough units for full time, but the point is to see how the weighted mean works. So for the A, or for the Math 21, we have 4 units times 4.0 GPA. This gets us 16 points. And then we do the same thing for the B. The B is 4 units times 3.0. That's 12. And we have, sorry, need that line there. We have 1 unit, but we got an F, so it's worth nothing. So this is my WI times my XI. And so we had sum of it. We're doing the sum, so we're going to add these up. This is 28.0. Now we need the sum of the weights. The sum of the weights are just the sum of the units. And we had 4, 4, and 1 is 9. And 28 divided by 9. Yeah, my trusty handy dandy calculator is 3.11, and it keeps going. So you would have a GPA of 3.11. That's how they calculate your GPA. And it's cumulative. So each semester it just adds it recalculates everything. It adds up all your total number of units and or all the total of this multiplication stuff done, and then divides by the total number of units you've taken. If we didn't have the PE in there, if we had no PE, we still would have had those same 28 points, but it would have been divided by 8. And that should be 3.5. Yeah. So the F in PE for a 1 unit, if it was a 1 unit course, brought your GPA down quite a bit, but that's for 1 semester. If that's the only really bad grade you have the entire time at school, you're going to have a lot more points by the end, and you might be up near 3.6, 3.7 quite easily. So that's how weighted means work. And I'm not testing you on that, but I think it's important that you know how to do it or what it is. Is there any questions on that? Okay. We will start 3.4. And 3.4 is on measures of position and outliers. And I think it's handy to draw that bell curve or the empirical rule again, because it's kind of important. So the mean goes in the middle. Then we have mu plus sigma, or 1 sigma, mu plus 2 sigmas, mu plus 3 sigmas, mu minus 1 sigma, mu minus 2 sigma, and mu minus 3 sigma. And if we do little dots to separate the regions, pretend those are straight lines. Oh, I like the different colors going together. That looks pretty good. That's driving me nuts. That is way not straight. That's the only one that's really bad. Let's fix that. And I can see I did space them evenly. Remember, going 1 deviation either way, cumulative value is 68%, which makes each of those 34%. And then we go out another deviation either way, and it's 95%. And this adds 13.5% to each group on either side. The next one down or next one out is 99.7%, and it's adding 2.35%. It's going down. And finally, the everything outside of that from -3 sigma all the way to minus infinity would be 0.15%, and the same thing as going up. And that needs a little tail on it right there. Think of it like this. The percentages add up to 100. So the percent adds to 100%. And it's kind of like the area under the curve. That looks bad. I'm just going to erase that and try that again. Area under the curve. So you can see between the two biggest, or these two right here, it's the highest amount. So the area in this region is a lot higher than in the other regions. That's why it's 34%. Covers a bigger percentage. Okay, so let's see how else I want to say this. If I wanted to do a percentage on like a number line, like starting at 0% down here and going all the way up to 100% at the far right, making it halfway is like the 50% mark. That's right where our median is. Usually, this is the way we record it, is median goes there. And let's see, I think this is misleading going down this branch right now. I think it's going to confuse you. Let's go back to that in a second, because I just did the bell curve and it's not quite like that. So let's say, let's talk about heights. Heights. Now I am 5 foot 5.5 inches. That half inch is very important to me because I am on the low end of the spectrum as a male. And this, you get varying amounts depending on where you look, but a common thing is showing that the mean is 70 inches with a standard deviation of 4 inches. Well, what is 5? 5 feet is 60 inches because 12 inches a foot. Add the 5.5. I'm at 65.5 inches. Oops. .5 inches. So if we think of this in terms of deviations, mu minus 1 deviation is 70 inches minus 4 inches is 66 inches. And I'm at 65.5. So on this little spectrum up here, let me get rid of this shading right there. I would be somewhere just to the left of it because I was lower than it. This is Gpa. And this is on a men's chart. Well, I wish Ariel was here because I know she's also smaller than the average height, but I don't know Ariel's actual height. This is Professor Jones. I was going to use Ariel. I'll give you a student I had the last time we met in person, right before the pandemic hit. I had a student named Brooke. Brooke was 4 foot 11 inches, which is 59 inches. So definitely shorter than Jones. But I'm like short for guys. Is like, if we look at up here, like what percentage of guys are taller than me, I have like all of this 50% right here is taller than me. Ooh, let me go to the purple or pink for a second. All of this 50% is taller than me. This 34% is taller than me. So at least 84% is taller than me. At least 84% of guys are taller than me. Which doesn't feel right. I can't, like, apparently a lot of people may be just 1 inch taller than me or 2 inches taller than me, where I don't feel like I'm shorter. And you would only really notice it if we're back to back and, you know, doing the ruler on top of the head thing. But that's how it is. So Brooke, she was at 59 inches, but women have a different mu and sigma. So women have a mu of 65 inches and a standard deviation of 3.5 inches. So the question is, am I shorter than more guys? Then Brooke is shorter of women or girls. Because it's clear I'm taller than her, but that's not really fair, you know, a fair assessment. Generally, men are taller than women. You can find many pairings that are not, but the majority is the other way. So we could try to do the same analysis with Brooke and do this subtracting thing. 65 minus 3.5 is 61.5. And if I try to subtract another, 61.5 minus 3.5, I'm down to 58. So Brooke is also between -1 and -2. So she's between -1 and 2, and so am I. So the way they do it is called the z-score. We can compare apples and oranges, so to speak, if we just get a common thread. And the common thread is called the z-score. The z-score is really just the multiplier on the standard deviations. Right there. So we have a way of, rather than just going, well, exactly 1 or exactly 2, maybe we could get a decimal value and then we know just exactly. So the way the z-score works, well, if I say my score, this is how they come up with it. I don't want that bar. There we go. Rather than putting in a number for my score, I'm just going to put z in. And the way they figure out how to get a formula for z is first they subtract mu from both sides. And we get x minus mu equals z times sigma. And they want to get z by itself, so they divide both sides by sigma. And we get the formula for z-scored. Z equals x minus mu over sigma. That's pretty important. This is how we compare apples and oranges. And the way, the how it differs and how we're allowed to do it is just like up here. I'll go back to it in a second. Just like up here, I put my ranking on one thing right here. I put my mark where I was at relative to the other guys. What we're going to do is just make it relative to everyone's individual gender. By switching to z-score, for the z-score curve, the mean is 0 and the standard deviation is 1. And now we're putting once we get a z-score, everyone goes on that same curve with the same mean, the same standard deviation, and we go from there. So let's apply that to what we learned or what we have with me and Brooke. So my z-score Z David. I do want to continue sharing. Yes. My z-score is, well, my X value was my height, 65.5 inches. The mean for guys was 70 inches. And the standard deviation for guys was 4 inches. That gets me negative 4.5 divided by 4.0. And if I do that in my calculator, I get negative 1.125. Now we'll do the same thing for Brooke. She was 59 inches tall. But for women, the score was 65 for the mean, with 3.5 as the standard deviation. 59 minus 65 is negative 6 over 3.5. And that gets us negative 1.71. Which means we'll do our little bell curve again. God, that's kind of lame looking bell curve. That's too flat. There's mu minus 1 sigma. There's mu minus 2 sigma. Negative 1.71 is a little bit closer to the negative 2. So Brooke is like there. And David is like here. Which means although a majority of guys are taller than me, even more girls are taller than Brooke because she has this extra percentage right here. So z-scores allow us to compare ourselves to other situations. In fact, Brooke is really close to a score for the outliers. When we do this, these charts, I'm going to go plus 1 sigma and plus 2 sigma. Anything past that, past the negative 2 sigma or positive direction and plus 2 sigma, that is interesting. It like doesn't matter. Nope, that's doing it different. Okay, it was the back and forth. I thought I was like the color stayed the same. That's neat. These regions, the regions outside of 2 sigma are the outlier zone. That's not a technical stats name. That's me putting my spin on the name. What that means in English is z-scores less than negative 2.0 or z-scores greater than 2.0 are generally outliers. Sometimes that are, there's not a lot out there. How does that relate to guys? How could I get a z-score of 2.0? On guys, we had 70 inches plus 4 inches, or 70 inches was mean, and 4 inches was sigma. So mu plus 2 sigma, that here z equals 2. 70 inches plus 4 inches, or 2 times 4 inches is 8 inches, is 78 inches. Well, 72 inches is 6 foot. So 78 inches is 6'6". Yeah, you really don't meet a lot of people taller than 6'6", do you? I can probably count on my hand the people I've met in person that were taller than 6'6". And only 2 of them are coming to mind. I can only think of 2 that I've actually met face to face in person. Now, I know there's more, but that's kind of tall. And if we went the other way, we did 70 inches minus 8 inches. This is 62 inches. That's 5'2". So guys shorter than this are outliers. And it doesn't mean there's anything wrong with being an outlier. Don't assume outlier means like misfit or, anything like that. It just means that they're not in the group of the what's considered the normal or the norm. Oh God, the number of guys that I can count on my hand as well. I can think of 3 right now that are shorter than 5'2", which is kind of interesting. 62 inches is our cutoff for outliers for men. Brooke was 59 inches and not an outlier. So, and she's shorter than. So that's some fun ways to look at it. And that's how we use z-scores. It allows us to take people from 2 different graphs and put them on the same graph and compare them directly rather than going, well, which one's more relative? And this tends to work really, really well. Z-score is really for bell curves. And we use mean and sigma. When we want to compare stuff on a skewed graph, and we don't do it that often, but for skewed graphs, instead of the mean, we use the median. And instead of standard deviation, we use something called the IQR. The IQR stands for Interquartile Range. So this is where I'm going to do my little percentage line. We have 50% in the middle, 0% right here, 100%, or the maximum value over here. 0% would be the minimum value. 50% is the median. And halfway between 0 and 50 is 25%. This is the first quartile. And I usually say Q1, because let's face it, that's a lot easier to remember. Halfway between 50 and 100 is 75%. That's the third quartile. And that's Q3. So this is kind of like off of the meaning of percentile. And if you took the SAT, not everyone does. I don't remember if I took it in high school. I didn't go to college till another 10 years. The SAT reports scores as percentiles. For a given percentile, that percentage of the people that are in the same category have a lower score, have a lower value. That's just the general meaning of percentiles. In terms of SAT, what an example in the SAT is, let's say you got the 96th percentile. It means 96% scored lower than you on the test, that same test. And it's kind of weird to look at how other people did it. Another way of saying the same thing is you scored higher than 96% of the people. So that's how percentiles work. There will be problems that ask you about percentile. Quartiles just hit those multiples of 25%. Just like a quarter is 25 cents, a quartile is 25%. So the quartiles happen at these values up here. These are the 5 different markers for quartile. First quartiles, the median is technically a second quartile. And now we're not doing it by, the mean isn't related at all. It's just the number of exact people that did it. It's the number of people, not the score they got, but the number of people that got below you. We're not taking a mean SAT score and figuring out what the mean was on that SAT and relating you that way. We're just saying what percentage of people are below you and what percentage of people are higher than you. You're at 96th percentile. This means 4% did better. So that gets it. Now that we know what quartiles are, that gets us back to interquartile. The interquartile range remember when we did range, we subtracted highest minus lowest? Similar here. We're not doing the highest though. We're doing the third quartile minus the first quartile. Okay. And the way we flag outliers here, so outliers are related to the lower and upper fence. For both of them, for both, you need the IQR. And then multiply it by 1.5. When we mark the lower fence, the lower fence equals the first quartile, whatever that value is, minus 1.5 times the interquartile. And I'll show you this in a picture in a little bit. The upper fence is similar. We're going to add 1.5 times the interquartile, but this time, instead of going off the lower part of the range, we're going off the upper part of the range, Q3. And then anything outside the fences is an outlier. Which is really lower than the lower fence. Let's say less than the lower fence. Or greater than the upper fence. Okay. Thankfully, you don't have to go through the data and sort it and figure out where the percentiles are, where the first quartile is, the third quartile is to do this. StatCrunch will give these values to you. In StatCrunch, we're going to go to stats, summary stats, columns. I'll give you a second to write that down, and then we'll open up MathLab and go take a look at it. And then we'll take a little break. All right, I'll switch over. My MathLab, sign in. Get rid of that top row. All right, we were doing heights. The heights here are recorded kind of funny. Some people did foot and inches. Some people just did inches. So maybe let's do it on the age category. We're going to go stats, summary stats, columns. So that's your path when you're doing this. I'm going to choose age. And if I just wanted to choose all the quartiles and then the range, min is the 0% quartile. Q1 is the first quartile. Median was the second quartile. And I think we scroll down and we find Q3. Yep, there's Q3, third quartile. And max is on here for the final quartile. And then IQR, I believe, is below it. There it is, IQR. So I've got them all. So the lowest age person that took the survey was 14. The oldest person that took the survey was 79. The IQR is based off this 79 and 33. So 33 minus 19 is 14. So I'm going to write these on my little on the tablet real quick, and then we'll go back over to it in a second. That's my dog making noise in the background. We got 19 and we got 33. And we have the IQR is 14. I'm going to come back over to that thing and show it. So if I want 1.5 times 14, this ends up being 21, which is 14 plus half of 14. It's 21. So my lower fence is Q1 minus that 1.5 times the IQR, which is 19 minus 21 is -2. No one was -2 years old, so no one is younger than that. There's no outliers to the left. No one is younger than -2. And since I've already done 1.5 times the IQR, I'm not going to recalculate it. To do the upper fence, I'm going to do Q3 plus 1.5 times the IQR. Q3 was 33. And 21 was 1.5 times the IQR. That is 54 years old. Now I know there was at least someone in their 70s, so 79, 74. There is an outlier, at least one outlier bigger than this. At least one person greater than this value. Or older is another way of saying it. Greater or older than 54. So we will have outliers to the right. That's how we work with the skewed groups. We're doing that. And we come back over the data set and actually look at it, sort it by age, and see just how many people were in that category. So I'm going to come over to age, and I'm going to just click sort table by descending. I've got a 79, a 65, 79, 65, 63, 61, 61, 58, 57. That's the cutoff. I had 7 outliers in this data set. Most of the people that took it were below, under 50, to be honest. And with that, we're going to pause for a second, go take a 5-minute break. I'll pause the video. Resuming recording now. We were at the end of 3.5. So I would reference you to go see the 3.5 video that's in my other stats course, since thankfully it's recorded there for those of you that didn't attend class but are watching these. The quick and dirty of it is the 5-number summary uses the min, Q1, median, Q3, and max that we were just doing. And then there's some steps to drawing the box plot by hand. You can find a 5-number summary. Then you find the fences using the IQR and the lower and upper fence. We did this in the video already. What's new is we're going to draw a number line that includes those values. So I did a number line that included those values. I even included the lowest fence, even though it's not part of the stuff. You make vertical lines for Q1, median, and Q3. And then the left line there is the lowest non-outlier, which in this case happens to be the minimum because there's a fence over on here. There's a fence over here. Fence. And there was a fence right here at 54. The lowest non-outlier was 14, which was the min. And then we do the highest non-outlier, which was 52, which you pull from the data set by looking at it. You connect those to the box using lines. I'm going to get rid of this stuff right now. And then any outliers you do with asterisks. The box can show skewness. Longer whiskers indicate skewedness, like the right whisker here is much longer. The whisker is the thing that sticks out, kind of like a cat's face. The whiskers stick out like that. That's kind of the idea of a whisker. In the sense, this one on the right is a lot longer. It's skewed to the right. Also, how narrow the box is can kind of show that a lot of data is packed up in one spot, which means there's going to be a hump there. So there's going to be a hump on the left side of the graph that's not really centered very well, which means the humps on the left, it's skewed right. When you want to see it in StatCrunch, we'll do it from scratch for the video real quick. You go graph, box plot. You choose the column you want to do. You use the fences to identify outliers, and then you're going to draw boxes horizontally. You click compute, and it gives you the box plot. If you put your cursor over it, it'll tell you where it got the values of. It even says 7 outliers. It only shows 6 of them. But if I have this data sorted or unsorted the way it came, I can go through and click on an outlier and see where those are highlighted. So this outlier dot represents 2 rows, 21 and 25. That dot says row 113 is way down here. And that's the idea of the box plot or the whisker box plot, whisker plot. It's got all sorts of different ways of saying it. That's it for today, though, folks. You guys got any questions?
No questions.
All right. Well, then I will see you guys next week. Have a good day.
Have a good day.
Have a good day.